Okay, so let's run through a couple more examples of using this quadratic formula to make sure that we understand the situation. First of all, if we're going to solve using the quadratic formula, our very first set of steps will be to rewrite any equation that we have into the standard form of ax squared plus bx plus c equals 0, which means in this first case, 4x squared equals 8x minus 13, I'm going to have to subtract 8x and add 13 to both sides before I can do anything. So I'm going to get 4x squared minus 8x plus 13 equals 0 as my initial equation, which I would identify a is equal to 4, b is equal to negative 8, and c is equal to positive 13. All right, so these are the substitutions that we make into our formula to solve for x. So we're going to get x is equal to the negative of negative 8. Right, so negative of negative 8, I'll just write it out. Negative of b plus or minus the square root of b squared, so negative 8 quantity squared, minus 4 times a, which is 4, times b, which is 13. This should be interesting. All divided by 2 times a, so 2 times 4. So now let's go through the steps to simplify all of this. X will equal, in this case, positive 8 plus or minus the square root of, we're going to get 64 minus, let's see, 4 times 13 is 52, just like a deck of cards, and 52 times 4 is going to be 208. And again, if you need to pause and work that out for yourself to verify I'm doing okay, that's fine. All of that will be divided by 8. Well, 64 minus 208. Well, we're going to take 208 and subtract 64 from it, and then attach the negative sign. So we're going to get 4. 20 minus 6 is 14. So x will equal 8 plus or minus the square root of, in this case, negative 144 divided by 8. And we might recognize that negative 144 is going to give us a complex number, right? This is actually going to become x equals 8 plus or minus 12 times I, the I stands for the square root of negative 1, remember, divided by 8. And so if we simplify this a little bit right here, we want to write this in standard form. We're going to get x is equal to 8 over 8. Right, in standard form, we have a real part and a separate imaginary part, plus or minus 12 over 8 times I. Well, we should reduce all of our fractions, of course. I'm not going to leave 8 over 8 on a test, so I'm going to get 1. And this will be plus or minus. If we divide both the numerator and denominator by 4, we get 3 halves times I. So that's our two solutions, 1 plus 3 halves I, and 1 minus 3 halves I. All right, let's try the next one. We've got x squared minus 2x minus 15, same deal, right? We have to set this to 0 before we even begin. And so setting to 0, we get x squared minus 2x plus 15 is equal to 0. And so we identify a, b, and c. If there is no coefficient present, then we assume that it's 1, not 0. Be very careful with that. B, negative 2, and c is going to be replaced with positive 15. All right, so let's work out what's going to happen right here. We're going to have x equal to negative of negative 2 plus or minus the square root of b squared, so that's negative 2 squared, minus 4 times a, which is 1, times BC, which is 15, all divided by 2 times A. So that's 2 times 1. All right, let's simplify down what we have here. X will equal positive 2 this time, right? The negative of negative 2, plus or minus the square root of negative 2 squared, which is 4, minus 4 times 15, which is 60, all divided by 2. Let's continue to simplify. X will equal 2 plus or minus the square root of negative 56 divided by 2. All right, we need some perfect square factors of negative 56 if we can reduce this thing at all. So let's see. Negative 56. Negative 56. What do we got here? Well, it's certainly divisible by 2, right? Because if you divide by 2, you're going to get 28. But 28, that's divisible by 2, right? That's, as a matter of fact, 4 times 7. And 4 is a perfect square factor. So, in fact, 56 is the same thing. The square root of negative 56, we'll put it over here. The square root of negative 56 is really going to be the same thing as the square root of negative 1 times the square root of 4 times the square root of 14. And when that reduces, that's going to give us x is equal to 2 plus or minus 2I times the square root of 14, all divided by 2. But in standard form, we want to separate out the real parts from the imaginary parts. And if we separated this into two fractions, we'd have x equals 2 over 2, which is 1, plus or minus 2I squared of 14 over 2, and that's just I times the square root of 14. And so, in this particular case, we get another imaginary answer, or complex number answer. And so we're done. More to come in the next video.